C++ is one of the most widely used programming languages globally. It is integral to operating systems, embedded systems, and graphical user interfaces. As an object-oriented language, C++ promotes code reuse and reduces development costs. Its portability allows developers to create applications for multiple platforms, making it a versatile choice. C++ offers numerous features that developers appreciate. It supports multiple programming paradigms, including procedural, object-oriented, and generic programming. The language provides high performance and can interface with almost every other programming language. C++ also includes advanced features like multiple inheritances, templates, and operator overloading, making it a powerful tool for experienced developers. To excel as a C++ developer, one must be proficient in Unix and C/C++ coding. Familiarity with web development tools, integrated development environments like Eclipse and Visual Studio, and modern SCM testing tools is essential. Additionally, a strong understanding of RDBMS databases and expertise in database administration and security standards are crucial. Modern C++ uses exceptions to handle logic and runtime errors effectively. Exceptions allow code that detects errors to pass information up the call stack in a well-defined manner. This method separates error detection from error handling, making the code more robust and easier to maintain. Exceptions are preferred over traditional error codes for their clarity and efficiency. The performance cost of exceptions in C++ is minimal if no exception is thrown. When an exception occurs, the cost of stack traversal and unwinding is comparable to a function call. Although additional data structures and instructions are required, the impact on performance and memory footprint is generally insignificant, except in memory-constrained systems or performance-critical loops. Assertions. C++ uses two mechanisms to detect runtime errors: exceptions and assertions. Assertions are used during development to test conditions, halting execution to inspect the program state. Exceptions, on the other hand, handle runtime errors, allowing the program to continue execution from the appropriate catch handler. This distinction helps maintain code integrity and manage unexpected conditions effectively. C++ has built-in support for exception handling, a significant advantage over C. Exceptions in C++ can be synchronous or asynchronous, such as keyboard interrupts or disk failures. The language uses specific keywords like try, catch, and throw to manage exceptions, ensuring that programs can handle runtime anomalies and abnormal conditions gracefully. Using exceptions in C++ separates error-handling code from the normal program flow, making the code easier to read and more robust. While exceptions can be costly, their impact on performance should be measured and evaluated. Exception safety should be considered from the start, ensuring that new code is compatible with existing code and that exceptions do not cross defined boundaries. C++ remains a powerful and versatile programming language. Its robust error-handling capabilities, combined with its performance and portability, make it a preferred choice for developers worldwide. Understanding and utilizing exceptions effectively can significantly enhance the quality and maintainability of C++ code.